still use
We
it.
actually will talk about it today a little bit, and we'll use
The
it
unit of
more
tears.
tomorrow. But, yeah, that's a yawn.
The unit of tears.
Cocoa is boring.
It's fun to say though.
Yeah, that's
6.18, yes?
not really.
No?
We'll get there in a few minutes.
Okay, but if I wanted to write something down in my notes, I could?
Sure.
Okay.
That's a big one.
What?
Okay. If you have talked to anybody or you know anybody that has taken this course in the past or anything like that, you may have heard of the phrase the chart.
Do I want to have heard of this?
This
word?
is the chart. Okay, so I will write some things down. We'll talk about what they mean later on, but this is the chart.
Do we copy
So,
down the chart?
Here we go. First thing we're going to do is we're going to put a few things down the left-hand side. First one says,
Can I take your recycling?
you
for
certainly
Ace?
can.
Thank you.
My pleasure. Thank you. Anybody know what that is?
Sine, O.
That is. Came back.
I dumped it in.
Thanks. That is called theta. That is another Greek letter. Okay. We will use theta very, very often to represent angles while we do trig. Theta is probably the most common variable Greek letter we will use to represent angles. So we have the sine of theta, we have the cosine of theta, and we have the tangent of theta. Across the top, we have some of our favorite angles. 0 degrees, 30 degrees, 45 degrees. What did you say is next?
60.
60 degrees.
90.
And 90 degrees. Okay. 0, 35, 40. Yeah, good. 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. The sine of 0 degrees is 0. The sine of 30 degrees is 1/2. Sine of 45 degrees is square root of 2 over 2. Sine of 60 degrees is square root of 3 over 2. Sine of 90 degrees is 1. Cosine of 0 degrees is 1. The cosine of 30 degrees is square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2. The cosine of 60 degrees is 1/2. The cosine of 90 degrees is 0. There is an interesting relationship between tangent and sine and cosine, in that tangent of theta is equal to the sine of theta divided by the cosine of theta, sine over cosine. So we can use that to help set up the chart. If this statement is true, then what is the tangent of 0 degrees?
0.
It is 0 because it's 0 over 1, which gives us 0. The tangent of 30 degrees starts to freak people out.
No thanks.
It would be 1/2 over square root of 3 over 2. But that's complex fraction. In a complex fraction, if the two denominators are the same, we can just zap them, which would give us 1 over square root of 3. But we can't have a radical in the denominator, so
Multiply by yourself.
yes, that's correct. Multiply by square root of 3 over square root of 3, which gives us over what? 3. So the tangent of 30 degrees is square root of 3 over 3. What is the tangent of 45 degrees?
1.
1, because it's the same thing. It's something over itself, which gives us 1. The tangent of 60 degrees is not as difficult as the tangent of 30. because if we zap the denominators, all we have is square root of 3 over 1, which is simply square root of 3. And the tangent of 90 degrees is
No.
0, right?
Indeterminate? Is that the word for
Why
it?
not 0?
Because you can't have zero.
Can't have 0 in the denominator. So, it is
Nada.
undefined. There is the chart.
This doesn't look too traumatizing.
Let me tell you about the chart.
I find my existence more
You must know it. Period. You must know the chart, period. When I say that, I don't mean you must be able to recreate the chart. I mean you must know every piece of information in the chart. Backwards, forwards, left, right, up, down, inside and out, and all of that stuff. In other words, when I ask, what is the cosine of 30 degrees, we can't be thinking, okay, cosine of 30 degrees, so that's the second one over. We go from there and there, and it's square root of 3 over 2. Okay, when the question comes, what is the cosine of 30 degrees, the answer is square root of 3 over 2. Bam, done. It's kind of like times tables. Okay, when you are asked what is 7 times 6, what do you say? 42. You don't say, let's see. 7 sixes, so 6, 12, 18, 24, 30, 36, 42. So it's 42. You don't do that, right?
I mean,
You shouldn't do that, especially if you are an honors algebra 2 student.
Ha 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 ha. Funny, funny.
You must know this stuff, okay? Not in a recreate the chart kind of way, not in an analyze and figure it out kind of way, but in a memorization, know your times tables type of way.
I know.
And in that mode, you listening? Starting on Friday, in 3 days, she knows what's coming. Starting on Friday, I reserve the right to give you a quiz on this chart at any time for the rest of the year.
Oh,
Know it. Memorize it. Backwards, forwards, everything about it. Okay? I will give you a little preview of what a chart quiz will seem like, will be like. Okay? So when it comes time for a quiz, I'll say, all right, take out a piece of paper, put your name on it, and put 1, 2, 3, 4, 5 down the side, because there will typically be 5 questions. And I'll give you a couple minutes to do that. On the piece of paper, you may not write down the chart. You may not write any triangles, and you'll see how those apply in a minute or two. Okay? Just your name and 1, 2, 3, 4, 5. Once everybody's ready, this will be exactly how it will go, the same pace and everything. Okay? So just hear me out for the next few seconds. This will be how the quiz will work. Question number 1, sine of 30 degrees. Question number 2, cosine of 45 degrees. Question number 3, tangent of 60 degrees. We'll go on and we'll do 5 questions. After the last one, once I give you the 3 or 4 seconds to write it down, then I'll say, okay, send them forward. And that'll be it. The entire quiz will take a minute. There will not be time to write things down. There will not be time to analyze and do all of that stuff. You have to know it. That starts Friday, or it can start Friday. Anytime from Friday on for the rest of the year, I reserve the right to quiz you on this chart. Okay? That's how important this is. Remember, all year I've been talking to you about trig, and I've been saying something like, if you do what I tell you to do, you'll be fine. This is number 1, and this is like the primary thing. If 3 weeks from now I ask you what the sine of 30 degrees is, and you start trying to do the chart, or write down the chart, or look up the chart, or write things down, or something like that, it's going to be a really, really long last 3 months of the year for you. Okay? Do it. Learn it. Memorize it. Do what you got to do so that when you come in on Friday, if not before, but when you come in on Friday and I ask you what's the cosine of 45 degrees, you're able to tell me it's square root of 2 over 2 without even worrying about it. Okay? There will be 2 or 3 different things that you'll have to memorize here. But everything else we'll work through. Okay? But you got to know this stuff. Right. A, you got to memorize all the things I tell you to memorize. And B, you must do your homework every night. Okay? For those that have been doing that, and you feel that sometimes you haven't been rewarded, sometimes you're, I'm doing my homework and I'm still not doing well or whatever, trig changes things. Trig is the big equalizer. All those people who've been kind of skating through on their brilliance and things like that, trig kind of comes up and smacks you in the head. For all of those people who've been working hard and haven't been getting the grades that they feel like they deserve, trig is usually when things turn around. Okay? So if you're doing your homework, great. If you're not doing your homework, better get on it. Rachel, what did I lie about?
Which part?
Is what I said fair and accurate?
Said the same thing that you said last year.
Mm-hmm. And was it fair and accurate last year? Okay. From somebody who took the class last year. Okay.
The one who still uses this year.
That, good point. All this stuff will come up in calculus. So if you know it now and therefore you'll know it when you get to calculus, that will be very helpful. At some point early on in the year, your calc teacher will ask you what's the sine of 30 degrees, because it'll be in the middle of the problem. And some of you will go, oh, it's 1/2. And your calculus teacher, be it a he or a her, will say, good. And the people that don't get it, that are like, oh, that's right, they'll start to get a little nervous because they'll say, oh, I really did need to remember this, didn't I? So you might as well learn it now. Okay? All right. Questions? Friday? I can give you 37 quizzes. I doubt I will, but I can. Most likely you'll get probably somewhere around a half a dozen throughout the course of the rest of the year. And it could be at any time. It could be at the beginning of class, it could be in the middle of class, it could be the end of class. Monday, Friday, makes no difference. It could be right in the middle of doing a problem and say, you know what? Chart quiz, let's go. I could do that. Okay? I reserve that right starting on Friday. Okay? I'm giving you your warning. Should it really take more than 3 days to learn this chart? Really, truly, it shouldn't, right? Okay?
Maybe.
It's going to take a little work to memorize it, but you can do that. All right.
It's a triangle.
30, 60, 90 triangle.
I'm kind of showing you something.
My favorite.
What is that?
30, 60, 90 triangle.
Yeah, it's a special right triangle, right? You learned them last year, I assume?
Mm-hmm.
Yeah.
Can you tell me the lengths of the sides of that triangle?
Sophia doesn't know.
There was some math involved.
It was like 3 square root 2.
There
Not
was
quite
some
right,
math
but
involved.
I like the fact that you're going in that direction. That's good. Second hour kind of went. So I thought I had gone deaf. But lengths of the sides of this triangle. Say A.
Square root something.
Yeah, I don't tend to like X's. I tend to just use 1 instead. It'll make it easier. Where would the 1? He's thinking.
Oh, that's okay. The 1 goes to that's the shortest length.
The 1 goes there.
And then the square root of 1 is the other side of I 1.
The square root of
like 1, 2, and then
It's
something
like
square.
1 square root 3. 1 square root 3.
It's 10.
Oh.
Okay, I don't expect you to remember all of that from last year. I hope that you remember that something like that existed.
Mm-hmm.
And then when we put the numbers back in, you go, oh, yeah, I remember that now. That's good. I'm fine with that.
Oh, this one's the.
What about this one?
The one I can never remember.
No, or is it 2 squared? Or no, it's
So what are the legs?
1.
1,
Yeah.
1,
C squared.
Square root
Oh,
square root of,
2, 3.
Thing.
remember that at all?
Sadly.
All right, so here's my question. According to these triangles, oh, that's right. Remember SOHCAHTOA? What does SOHCAHTOA mean?
Sine over
Sine is
hypotenuse.
opposite over
Yeah, make sure that those words go in there, because I've heard a lot today of sine opposite hypotenuse, which I don't really know what that means. So,
over.
sine
Opposite over.
is opposite over hypotenuse. Sine is opposite over hypotenuse. Keep going.
cosine is
Cosine is adjacent over hypotenuse.
Tangent is
Tangent is opposite over adjacent. SOHCAHTOA. Okay there? So according to SOHCAHTOA and these two special right triangles that you have here, can you tell me what is the sine of 30 degrees?
1
How'd you get it?
opposite over.
Found the 30-degree angle. I said sine, so you're saying opposite over hypotenuse. Opposite is 1. Hypotenuse is 2. 1 over 2 is 1/2, which is what we put in the chart for the sine of 30 degrees. So remember when I was saying that you need to memorize the chart, you can't like draw triangles and things like that? That's what I mean. All this stuff, everything that's on the chart you can get from these two triangles. Well, not the zeros and the 90s, but the 30s and the 45s and the 60s. So what is the, according to that and these triangles, what is the cosine of 45 degrees?
Square root of 2 over 2.
Okay. Cosine is adjacent over hypotenuse, right? So adjacent is 1. Hypotenuse is square root of 2. So it's 1 over square root of 2. But then we will rationalize with square root of 2, which will give us square root of 2 over 2. Make a little sense?
Yeah.
Okay. So it is, we're really in a lot of ways just kind of memorizing everything from this. We put it into a chart, we make it more condensed, we make it easier to memorize, because we are going to use it that much. Okay? I just had something in my mind that I was about to do. Yes. Now, there's a lot of stuff up there. There are a couple of, I don't know if it's shortcuts or tricks or whatever to learn it. Okay? Here's one of the things. When you look at sine and you look at cosine, you probably already saw this. What can you tell me about sine and cosine?
They're opposite.
They're simply reversed, right? 0, 1/2, root 2 over 2, root 3 over 2, 1. 0, 1/2, root 2 over 2, root 3 over 2, 1. So you've already cut in half the number of values that you have to remember. You just have to remember where they go. Okay? Here's number 2. Could we have root 3 over 2, root 2 over 2? Could we rewrite 1/2 as the square root of 1 over 2?
Yeah.
Can we do that? I mean, it's true, right? You got to simplify it. You got to write 1/2. But in terms of a memorizing type of thing, 3 over 2, root 2 over 2, root 1 over 2, root 0 over 2. Can we do that? Is that fair?
Root 4.
you think? Makes it a little easier, doesn't it? And then, so that sine, root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2, which makes cosine root 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2, root 0 over 2. So hopefully that helps. In my mind, I still, in a lot of ways, do the tangent as sine over cosine. I'm not real good at memorizing, especially the 30 and 60 for tangent. So I will actually, in my mind, go back and kind of redo sine over cosine. Your call on how you remember it. But for me, the entire chart, memorizing this entire chart, for me, triggers off of remembering that the sine of 30 degrees is 1/2. As long as I remember sine of 30 is 1/2, everything else works itself out. So you guys have to figure out what works for you. But those are at least a couple little tricks that hopefully help you out and make it a little bit easier to memorize. Okay? Now officially in the book, we'll get to most of this stuff tomorrow. But you know, you've already figured out where I put it in the level of importance. So I wanted it out there right away so that you can start working on it. Okie dokie. All right. Now we'll officially go to 6-1. Huh?
6-1.
6-1. And then do you know what we'll do after 6-1?
Sleep.
6-2.
Wow. We're gonna go consecutively? That's astonishing.
Okay, chapter 6 has, I believe, 8 sections.
Yeah. No, 9.
9 sections. We will have a test after the first 4. We'll have a test after the first 4. And then we'll have a test after the last 5, obviously. All right. Section 1 deals with a lot of the fundamentals, a lot of which you learned last year. So some of this stuff you'll know, and we'll kind of work our way into it, but a lot of it's important also. So let's start with the question, what is an angle? It's a good question. What is an angle? Are they lines?
Is rays.
They're what?
Rays.
Rays. Are they rays?
Right?
Are they segments?
No, this is a radius and ongoing line, or that starts at 1 point and goes on.
Would you consider that an angle?
Yeah.
I would too. So what are we going with?
Rays.
Rays. Rays is a good one. Okay. I would say that the definition of an angle, what do they say the definition of an angle? Yep. To me, the definition of an angle is 2 rays with a common endpoint. That common endpoint we call the, make it singular, vertex. Yep. For now, we will measure angles in degrees. For now. I'll actually change that. I know. Jake's like, what do you mean for now? We can do something. Yeah, we can actually. It's coming up in probably in a week or so, I think. If you had to take a guess at the measure of that angle, what would you guess? 45 degrees? Is that a reasonable guess? Is everybody okay with that being a reasonable guess? Somewhere around 45 degrees?
I agree better.
Okay. What if I said I don't agree?
Could be 30.
I mean, I guess you could check the same probably.
What? Matt, what'd you say? You didn't say anything. You said something. We don't know what?
We don't know what it is.
We don't know the measure.
It's a theta.
And I agree with that. I agree that we don't know what the measure is. Because if I do this, does that clarify it at all?
Oh.
An angle has 2 sides. One side is called the initial side, and the other side is called the terminal side. The initial side, we're going out on a limb here, the initial side is where the angle starts, and the terminal side is where the angle ends. Yes, I like that.
Wow.
Can you tell, given what I have drawn here, which is the initial side?
Mm-hmm.
The bottom one. And the terminal side is the top one, I would agree. Can we now say that the measure of that angle is approximately 45 degrees?
Yes.
Yes, we can. Because it starts
Now it's
here
actually an angle.
and it ends here. Now, if you wanted to say it was a little less than that, I get it, but
Oh.
let's just go with 45 for right now. Okay? Is that a fair angle? It
Yeah.
absolutely is. Can you tell me what you think approximately the measure of that angle is? If that black angle, the original angle, is 45 degrees,
175.
Well,
315.
I love watching people try to do calculations. I don't want to punch
Oh,
in
wait,
my
a circle.
calculator. Wait, are you actually
315.
What is it?
315.
315. So does everybody agree that the blue angle is approximately 315 degrees?
Mm-hmm.
Okay. I do not. And here's why.
Oh, because we don't know that that's really a circle.
An angle that goes in the counterclockwise direction, is said to be positive. An angle that goes in the clockwise direction is said to be negative. Therefore, the blue angle should actually be negative 315 degrees. And now I do agree. Huh?
What did you just say about the direction?
If it goes counterclockwise, it is positive. If it goes clockwise, it is negative. Okay? Is this a fair angle to draw, given the two sides that we have there?
mm-hmm.
Is that a fair angle to draw?
Maybe. No, I don't know.
Oh, wait, yes.
Why not?
You started at the top.
It's a weird angle, isn't it?
You started at.
Did we start at the same initial side?
Yeah.
Did we end at the same terminal side? Yeah, we did. What would you guess would be the measure of that angle, the green angle? I'm sorry, what'd you say? 405 degrees. How'd you get 405 degrees? What does 360 represent? One full revolution. Okay? Is it possible to have an angle of 405 degrees?
Yes.
Okay, this would be a representation of 405 degrees. You ready?
Clock.
You can't do that.
Just kidding. Did I rotate 405 degrees?
Yes.
Yeah. So that's okay. We can do that. All right? 360 is one revolution. What's 2? 720. You know what 3 is? 1080. Yep. Keep going, stuff like that. Yeah. So all of those are okay. And we are going to be dealing with all of those. Now here's something interesting about the angles. Now, did we use the same angle every time?
Mm-hmm.
No.
No, We did use the same
Initial
initial side and the same terminal side, but they were different angles. Angle. That's impressive. I thought you were going head first.
Oh, just a pen.
Angles that use the same initial side and same terminal side are called coterminal angles. Angles that use the same initial side and the same terminal side are called coterminal angles. Same initial side, same terminal side. Do all coterminal angles have the same measure? No. In fact, we saw 3 different measurements right here, right? Oh, no, just kidding. Right? We just saw 3 different measurements right here. By the way, what's the difference numerically between the black angle and the green angle?
360.
360 degrees? What's the difference numerically between the black angle and the blue angle?
360.
360 degrees. Is that reasonable? In fact, that's always going to be true with coterminal angles. It's always going to be true. To get a coterminal angle, you can always, what do you think?
Add or subtract these.
Subtract
Or add 360.
or add 360 degrees. To get a coterminal angle, you can always add or subtract 360 degrees. Right? If we had a 45-degree angle and we wanted something coterminal, we could add 360, which we saw how that worked, or we could subtract 360. We saw how that worked. What's the difference numerically between the blue angle and the green angle? 720, which happens to be 2 revolutions. So we could add 360 and add 360 and add 360 and add 360 and add 360, etc. Just do that. True or false? I haven't been asked a question yet. True or false? An angle coterminal with a 45-degree angle is 360,045 degrees. Are those 2 angles coterminal? Yeah. Because we just added 360 1,000 times. A lot of times is true. 1,000 times was more specific.